Wayne Fagan, and I'm chair of D. Howard International Education Foundation. And with our colleagues at the University of Texas, San Antonio, Classic College of Engineering and Integrated Design, we're delighted to partner with Classic College and special guests to do these live virtual presentations of scientists to host schools. And we want to thank Mojave Valley Junior High for being kind enough to host this presentation. And I'll introduce our speaker in just a moment. We have from Classic College, Carlos Velez, who is going to be moderating the presentation. And also we have Jill Ford as a representative of Classic College. So Jill, do you want to have a word?
Sure do. Thanks so much, Wayne. First, I'm Jill Ford. I'm the Assistant Dean for Student Success in Classic College of Engineering and Integrated Design here in San Antonio, Texas. And so big hello to Mojave Valley Junior High. So great to see all of you today. Yes, so we're just so happy here in Classic College to be able to partner with Wayne, with the D. Howard International Education Foundation on the Rural STEM Initiative. And so really excited about this. A huge thank you to Aerospace Corporation for all of their support. I'll turn it back to you, Wayne.
Thank you. So our first, we have our speaker, Dr. Nahum Malamed, who I'll introduce in a moment, is from the Aerospace Corporation. And we have a whole team from the Aerospace Corporation with us. And Leanne, do you want to say a word, or Roxy, or are you going to say a word about who's with you today or anything about the Aerospace Corporation?
Yeah, I'm Leanne McGinley, but I'm going to hand things over to Roxy, and she's going to get us started for today. We're really excited to be here, so thanks for having us.
Oh, so is Roxy going to introduce Dr. Malamed?
Yes, I'm happy to introduce the Aerospace Corporation and Nahum.
All right, fire away, and
Well, hi,
then turn it
everyone.
over to Carlos,
We're
please.
so excited to be visiting your classroom today. My name is Roxy Abre, and we're from the Aerospace Corporation. Before we get started with the amazing Nahum today, we have a few slides and videos to show you so you can get to know aerospace a little better. Our first video is about the toughest problems in space that we face.
And so, Carlos, well, first, let me just mention that Dr. Malamed is the project leader for Embedded Control Systems Department at the Aerospace Corporation, and he will speak with you today. About half of this time will be a presentation from Dr. Malamed and then questions from the students. And his topic is near-Earth space objects. So, Carlos, I'll turn it over to you and Dr. Malamed.
Yeah, so I'll help just at the end here to help get any questions that we have at the end. So feel free to, as we go through the presentation, think through any questions. And then I'll pop back maybe around like 15, 20 minutes towards the end to help with that. So think of any questions you have, or if you do have anything along the way, feel free to throw them into the chat and we'll get this answered at the end. But I believe, yeah, I'll pass it back over to the aerospace folks and y'all can get us kicked off for the presentation. Thank you.
Okay, Dr. Malamed, it's all yours.
Okay, awesome. Before we go to Dr. Mohammed, we're going to go through some videos and some slides about the Aerospace Corporation so you all can get us to know us a little better. So the first video is about the toughest problems in space. So let's get started here.
Some of the hardest problems in the world exist far above the planet. Our job, to launch the smartest solutions, to protect our satellites, clean up our clutter, to propel breakthroughs in propulsion.
Oh, is it still playing? No? What?
To learn more about our place in the universe, to outpace emerging threats. Every day, the Aerospace Corporation uses the latest technologies to ensure our nation's safety and leadership in space.
Amazing. And this slide is a quick overview of our values and our vision as the nation's trusted partner in space. And then our next video is about planetary defense, which Nahum will discuss as well.
3, 2, 1, fire!
How do we protect Earth? Imagine a large asteroid headed toward Earth, traveling at over 30,000 miles per hour. An asteroid impacting Earth would greatly affect us and our civilization. How do scientists detect and deflect the asteroid in time to defend our planet? Dozens of asteroids are now being discovered and tracked nightly by teams of scientists operating large automated telescopes. Once an asteroid has been discovered, analysts calculate the orbital trajectory to understand where the asteroid is currently located, where it is headed, and whether there is any risk of impact with Earth. Analysts then calculate the exact trajectories to intercept objects that pose a threat. NASA's Jet Propulsion Laboratory, JPL, and the Aerospace Corporation have created an app that harnesses the power of JPL's asteroid dynamics engine to enable you to practice being a planetary defender and design a mission to deflect a hypothetical asteroid. Through the app, you will join a team with the goal of deflecting a threatening near-Earth object, a NEO, and preventing an impact. During your quest, you and your team will pursue the most cost-effective way to defend Earth before your competition outperforms you. Your team will balance the size and mass of the asteroid with the cost of launch vehicle options, adjust trajectories, rockets, orbits, launch times, and deflection sequences. And then, take on mission planning by deciding which launch vehicle option is necessary to deliver a deflection payload to the asteroid. The NEO Deflection app allows you to experience firsthand the constraints of asteroid orbit dynamics on the launch window to achieve mission success by deflecting the asteroid away from Earth using minimal resources. Will your team risk it all or play it safe? All teams are working together to defend Earth. Are you prepared to defend Earth? If so, navigate to the link to begin your journey into rocket science, learning about asteroid orbital dynamics, explore rocket capabilities, launch windows, mission trajectories, and encounter geometries, and take on the skills and technology to deflect asteroids. Will you take on the challenge of defending Earth against a threatening, near-Earth object?
Awesome. Well, thanks for watching those videos with us, and I'll pass it off to Nahum for the rest of the presentation.
Thank you, Roxy, and thank you everybody else, and thank you, Wayne, for inviting me, and thank you for the students that are interested in planetary defense, in how to defend our planet for the impact by asteroids. Welcome, everyone. If you have questions, send it over on the chat, and I will be happy to answer after the talk. And so I've been with the Aerospace Corporation for 23 years now, and I've been giving many talks to students like you in the hope of inspiring you to become rocket scientists one day. And some of your students are already working for aerospace today, doing exciting things like the one that I'm going to talk about now. And so with that, let's move on to the next slide and jump into the topic. So the first one is, because we are talking about asteroids, we would like to know how asteroids were formed. Where do they come from? And they came from the same place of the solar system. So the solar system was formed about 4.5 billion years ago, and this little video will show how it's all started. Yeah, if you can play the video. Yeah. So what you see here is a cloud of dust circling around, and a force of gravity pulls those particles together until they grow into a bigger and bigger objects. And when they are large enough, they are going to ignite and become a star. In our particular example is the sun. So the sun was created from a large collection of those particles that ignite when it becomes too large. The pressure is too large. So the sun contains most of the particles that were found in that cloud of dust. The leftovers are planets and their moons, and there are smaller left out objects which are called asteroids and comets. So those asteroids and comets also orbit the sun, but not along regular orbits, but along orbits that could intersect with the orbit of the Earth. And when they do that, there is a big collision. Let's look at the next slide and see how it might happen. So here's an illustration of an asteroid that collided with the Earth. There were millions and millions of these objects that collided, and they may have delivered water and minerals that are important for our life today over billions of years. So they not only created damage to the Earth, but they also delivered essential materials that enable life to exist on the Earth. But today we are concerned about the damage that they could do because we already have life on Earth. We want to preserve it. So let's go to the next slide. And here, the first thing we would like to do is to find those asteroids. How do we find asteroids? The way we find asteroids is we take a telescope to the sky in the middle of the night with the hope that we will have clear skies. And we try to find objects that move along the sky map relative to the fixed stars. And so what you see here on the screen is an asteroid that was caught on tape moving relative to the galaxies and the stars in the background. As soon as we discover a new object like this, we would like to put it into the catalog and calculate its trajectory into the future to make sure it doesn't come to impact with our planet in the future. And that's where experts that know how to calculate trajectories of asteroids and trajectories of spaceship come into play. Maybe one of you will become a rocket scientist that will know how to calculate the trajectory of those asteroids in the future. So now let's see if you can find an asteroid on your own. Sharpen your eyes, and I will ask Proxy here. So Proxy, move to the next slide. In this slide is a picture of the night sky before the asteroid was detected. So look at this picture for a few seconds and study the background stars and galaxies that are shown in the picture. In a moment, I will ask Proxy to move one slide forward, and there's going to be a new object that was added to the picture. And I'm going to tell you it's going to be very, very difficult to see. So let's see if you can see the new object that got added. Are we on the same one, on the next one, Roxy? Okay, so now it's the same night sky, except a small new object got added to it. This is what an astronomer who is interested in finding new asteroids would do. He will look at the sky and try to see objects that were added and moving relative to the stars. So Roxy, if you can go back a slide and do a back and forth a little bit just to see if the students can detect the new asteroid that got added. So go forward and backward and forward a couple of times. And any of the students can detect a new object that got added? It's very difficult, so it's a tough job. Maybe if you'll be an
I
astronomer.
got one who thinks he knows where it's at.
Yeah, there is one. Okay.
Yeah.
No. I want to get closer so I can see better.
Well, then grab this chair and move up. You just want to get closer to try to see better.
All right. I don't see what you're pointing at, but hopefully you'll be able to tell me.
He just wanted to move up closer to be able to try to see it.
Oh, okay. Very good. So it's not an easy task to find those asteroids. There are automated telescopes that look through the sky every single night when we have clear skies, trying to look at the pictures of new asteroids that might pop up into the image. All right, so what I'm going to do now, I'm going to help you with this object. So Roxy, if you move to the next slide. Okay, so there is a new object here, and the arrow here shows you where this object is. You can see it's not easy to look at it. Go back one step. You see, and there is a little dot that was added there, very little dot of a new asteroid that automated programs and sometimes the human eye would try to find in those images of the night sky. So as soon as a new object has been discovered, we would like to know where is it going. So they try to track the object. And if you move to the next slide, you will see that the object moved a fair amount relative to the background stars. And move to the next slide, please. And you see that after a day or two, the object moved further away. So now all we need to do is connect the dots. Let's connect the dots in the next slide. And we have the trajectory of this asteroid. At this point, every expert will ask himself, is this asteroid going to impact with the Earth in the future? So they sharpen their tools and their math and geometry, and they calculate where is this asteroid going to fly through space in the future. If they will find that this asteroid will collide with the Earth, then we have a group of experts that will gather together and decide what to do about it. How can we stop that asteroid from colliding with our planet and cause damage to our planet? So let's move to the next slide now and see how many objects actually, in fact, colliding with our planets almost daily. You see here a map of something that's called fireballs. Fireballs is just the light phenomena that occurs when small objects pass through the atmosphere. They get exploded in the atmosphere, they release a bright light for a few seconds. This is caught by satellites and put on that map. That map is maintained by NASA center that's called JPL, Jet Propulsion Laboratory. And here's the link to it right on the screen. Thank you, Lian. If you click it, you will get up-to-date information about those fireballs that hit our planet almost daily. Usually they don't cause damage because they are too small to hit the ground. They just explode in the atmosphere, vaporize, and cause no damage to the ground. But we are interested in the damage that larger objects that could collide with us may cause. So let's move to the next slide. And here is an example of an asteroid that in fact did collide with a planet and exploded in the atmosphere some 13 years ago. So if you play the video clip, that was taken from a dash cam inside the car of a driver going to work in the morning in Russia. You can see like a second sun appearing in the sky, exploding and releasing a very large amount of energy that did hit the ground and injured about 1,500 people. That's an example of a real asteroid that impacted with our planet in your lifetime, in our lifetime. Maybe you can play this video clip one more time for those that didn't catch it. That could be a morning anywhere around the globe. Anywhere around the globe, an asteroid could appear in the sky, explode, and potentially cause damage on the ground. Thank you. So now we are aware that our community and our livelihood could be impacted by those objects. It's a real thing that is in our near-Earth space, orbiting the sun just like we do, and those objects have been and most likely will collide with our planet in the future. So this brings up the question, how can we stop them? How can we stop the asteroid before it enters into our atmosphere and collide and cause damage? Was there an asteroid that hit your classroom or something? All right, so let's move to the next slide. And here we want to know what can we do to stop an asteroid that might come close to our planet. And there are many, many methods of doing that. The most popular one that was actually also tested in space by NASA is called the kinetic impact, which is a very heavy spacecraft that is launched on a rocket towards the incoming asteroid. It collides with the asteroid and try to either deflect it away from the Earth or break it into small fragments that will not cause damage on the ground. So that's why some of my best friends are rocket scientists. They decided to become experts on how to launch rockets and spacecraft into space to do useful things for us, for our community. Let's see how it might work out. So let's move on to the next slide and see what would happen if an asteroid were to approach our planet and we didn't do any action to prevent it. It will collide with our planet. It will create a huge explosion, and it's going to cause huge damage on the ground. We would like to avert the damage. So the next slide will show the concept of how we do that. So here is the asteroid as it approaches into our planet. We're going to launch a spacecraft to collide with the asteroid and basically just push it away and save the day on our planet, save the community. So this is one way of saving our community from those asteroids. If we don't have enough time to push the asteroid away, we might have to break it into small pieces to destroy it. And so the next slide will show you how that is done. So the asteroid is approaching our planet, and we're going to explode a big bomb next to it and break into small fragments that will be pushed away from our planet. We need experts that will be able to do that can design those spacecraft and design those devices that can push asteroids away from our planet, because otherwise they'll come and collide with us in the future and could cause damage on our community. So maybe some of you will decide to be experts on one of the topics that I covered here in this talk. So I think if we move to the next slide, it's going to show, okay, so here is a link to a web application. It's basically a computer program that we at Aerospace developed together with NASA's Jet Propulsion Laboratory. And in that app, we put in all of the physics and the performance that is needed to design a mission to deflect an asteroid. That's something that you can do on a desktop computer or a laptop computer from your own school desk or at home. Everybody can do that. And in a few minutes, I'm going to give a demonstration how this is done. You can fill the table here when you do that in class and create scenarios that you can exercise how to design a mission to deflect an asteroid. Let's move on to the next slide, please. This is a depiction of that app that I talked about with explanation how things should work. As you can see on the upper left corner, there is a control panel where I can select the number of rockets that I would like to launch towards the asteroid and the time at which the rockets get launched and the time at which the spacecraft collides with the asteroid and try to deflect it away from the Earth. And then down there on the left, we see the size of the asteroid, what it is made out of. We picked a specific object that was designed for the international conference that we hold every other year for planetary defense. And that is the object that was selected for the 2019 conference. That's the object I'm going to give a demo on in just a moment. Down on the lower left, you see two different orbits. You see the orbit of the Earth in blue, which is basically just a circle. It's the orbit of the Earth around the sun in the middle. And then the bigger ellipse in red is the orbit of the asteroid. As you can see, the orbits of the Earth and the asteroid intersect at some point, and that's the point of collision. On the right side, you can see an arrow that says deflect. And that's the mission that you are going to try out in your classroom, where you will be presented with an asteroid that's going to impact with the Earth. And your mission is to move it outside of the red circle. If you move it outside of the red circle, then you deflect it away from the Earth, and no one on Earth will be impacted and damaged by the asteroid. So now let's move on to the next slide, and I think that is another worksheet for a scenario that you might do. I think at this point, it's time for a demo, so I am going to share my screen now and show you how this is done. Okay, please tell me if you can see my screen.
Yes, we can see it.
Okay, great. Okay, so now I'm going to show you how this app works. So I started the app simply by going to the link that Lian sent you, and it will default to one of those objects that are in this list down here. As you can see here, there are a couple of dozen objects. They are all simulated objects. None of these objects is a real one, right? They are all fictitious objects that are designed to impact with our planet just for the purpose of exercise. So that those that would like to become experts on deflecting asteroids can train themselves on this asteroid deflection simulator. Just like a flight simulator that you might be playing as a computer game at home, this is an asteroid deflection simulator that you can try out at home. I'm going to select the object that I'm familiar with, which is the 2019 object. So the new object is going to load on the screen. Here is the orbit of the Earth around the sun, and here is the orbit of the asteroid around the sun. The sun is in the middle here. And as you can see here, right at this point here, the two orbits intersect with one another, and a collision occurs with the asteroid. The point at which the asteroid is going to impact with the Earth is dead center, right there. So what I would like to do is to launch a rocket. So I'm going to move straight to the intercept mode, where the system will allow me to select a rocket and try to move the asteroid away from the red circle, which is the capture zone. So to do that, I will do a couple of things. I will try to change the time at which the spacecraft collides with the asteroid. This is the time that is listed up here. This is the time before impact that I'm going to attempt to stop the asteroid. As I can see now, nothing can be done because we have just very, very bad geometry between our planet Earth and the asteroid, the object. We need to find a better geometry, a better way to connect between the Earth and the asteroid via a spacecraft. So I'm going to move that knob down here. And as you can see, as I move the knob and change the time, both the Earth and the object are moving along their respective orbits until I will find a combination that actually works. As you can see here, I was able to find a combination that allows me to calculate a connecting trajectory between the Earth and the object. So right here, the rocket was launched with a spacecraft. It's going to fly through space until it will collide with the asteroid and push it off. That is visible on the right side here. So we were able to push the asteroid from the center to a new location on our planet Earth. Is this a good outcome or bad outcome?
Good outcome or bad outcome?
Somebody is going to complain, right? Why did you move it to my backyard? So we don't want to have that. We're going to try to move the asteroid further as much as we can towards the red circle. But now we see the asteroid start to come back, which means we kind of exhausted this option here. And we might have to try the other parameter here, which is the amount of time from launch of the rocket from the Earth until it hits the asteroid. So I'm going to change this time a little bit. And as I do that, you can see that I was able to push the asteroid just outside of this red circle, and I was able to develop a missed distance here. It's a small missed distance, but it's good enough to save our planet from an impact by that asteroid. And that's what we call mission success. When you're going to try out this app in your classroom, it should be available very soon on the Aerospace Corporation website. We are in the process of releasing that app outside of our firewall. You will turn on that button here, which is going to turn on the team mode right there. Let's refresh the app by hitting the reset button here. And so now I'm going to turn on the team mode here. And as you can see, the asteroid is going to impact with our planet right at the center, like at the beginning of that scenario. And I can select a team name to do that, like it could be a name from a list down here, or you can type a name that might appeal to you. Maybe it's going to be Mojave. And you will set the team. So this is the team, and you'll be selecting teams of 3 or 4 students that will compete with each other to deflect the asteroid with the best performance. Also, you will be setting up the parameters of the scenario. So you might say, how many rockets are available to me from each one of those options here? I'm going to just select 2 for those as a demonstration. And I'm going to have to set the first time that the asteroid was discovered. How many years before impact was the asteroid discovered? So I'm guessing it might be 8 years before it's going to collide with our planet. And I say, how many rockets can I launch all at once? Let's try with 4. And how much money is available to us to do that? In billions of dollars, let's say $4 billion. And I'm going to give myself a few minutes to do that exercise. So every group in your students are going to be given the same amount of time in the same scenario, and you're going to do that. So I'm going to give myself just 1 minute for the demonstration, but typically it will be more like 10 minutes. So when I start that, you see the clock is ticking up here, and my job is now to deflect it and measure my best performance, which will be listed right here. Right now it's negative and it's red because the asteroid is colliding with the Earth. But I'm going to try the same exercise that I've done just a moment ago and show you how it might work. So I'm going to deflect it until I can move it just outside of the Earth with the given amount of time. And here it is. I was able to move it outside and got a performance of 0.251. which is now in green, which means that it's a success. You were able to deflect the asteroid away from the Earth. And in a few seconds, the time will be up. And at that point, the groups will stop and we'll see who got the highest performance. You can select from different launch vehicles and how many launches you might want to launch and see who can get the highest number right here. So time has expired. And that is a demonstration of our NEO deflection app. NEO is near Earth object like asteroids or comet. and we were able to move the asteroid outside of the capture zone and save the world. And I think with that, we can switch back to Roxy for concluding a couple of words. And I think that is the end of the presentation. Right, Roxy?
Hello, and I think we have a little time for Q&A here.
All right. Anybody have any questions that you want to ask about asteroids, asteroid impacts, near Earth objects, planetary defense? Remy. So on average, how's the biggest asteroid on average that we see that impacts our planet?
On average, they are very, very small. They will impact with the atmosphere, will just burn out. Perhaps once in a century or so, an asteroid the size of about 20 meters, which is about 60 feet, I guess, could collide with our planet and cause the kind of damage that you've seen in the video that I showed a few minutes ago. Everybody knows about the big asteroid that killed the dinosaurs. This happens once in 100 million years, so we shouldn't be worrying about those. They are very, very far in between, and we don't need to worry ourselves with the big ones. Also, NASA is monitoring the big ones, and none of the big ones that are known to us are going to ever impact with our planet. So we are more concerned with the medium-sized ones. Let's see, an additional question.
I think you had one in chat about the largest object in the asteroid belt right now.
Oh, okay, that's a good question. Yeah, the largest object in the asteroid belt is Ceres. However, most of the objects in the asteroid belt are locked inside that belt, and they will never come to impact with our planet. The orbits are such that they do not intersect with the orbit of the Earth. So we are actually safe from the vast majority of the asteroids that are in the asteroid belt, even if they're really, really big ones. Sometimes asteroids collide with one another, get ejected out of the asteroid belt, and then they could come and hit us, but they're usually fairly small. So those big ones, they are in the asteroid belt, but they're not considered to be hazardous objects.
So I have a question from a student who wants to know what's the fastest ever tracked asteroid in terms of speed?
So I don't know the exact number, but I think roughly asteroids, let's talk about typical speed of asteroids. So asteroids, they typically move in units of kilometers per second. So a kilometer is a large distance. And if an asteroid moves 10 or 20 kilometers per second, the asteroid can cover a huge distance in just 1 second. So this is already a huge amount of kinetic energy that is embedded into the asteroid. Each of those asteroids could cause humongous damage on the ground. The fastest one or the fastest that I'm aware of could move at about 30 or 35 kilometers per second. So they are faster than typical asteroids, which are like 10 to 20 kilometers per second. But all of those velocities will cause humongous damage on the ground. Maybe one more point is about the newest trend about objects that come from space, and these are the interstellar objects. Some objects have been identified as coming from outside of the solar system. That's why they're called interstellar objects. And they move super fast. They could move at 50 or 60 kilometers per second. And because of that speed, they never stay in our solar system. They enter, they fly through the solar system, and they exit the solar system forever. They are only seen once, and that's it.
Great questions. Any other questions in the classroom today?
Yes, I had a couple of them. One student asked, how many asteroids have impacted our planet? I would say what in the year, or as long as we've been tracking, I guess. And another one wanted to know, what are the asteroids generally made of?
And these are all wonderful questions. So I think for that, am I still sharing the screen? No.
Yes.
I don't think I'm sharing the screen, right?
You are. You have your app. You have the app up.
Yeah, you can see my screen?
We have your app, yeah. The
Excellent.
Neo app.
So let me go to the NASA Center website. This is the website that we use a lot to find information about asteroids. The question was how many asteroids we are aware of today. So to that, I'm going to go to that tab here that says Discovery Statistics, and it can give us the total asteroids that we are aware of as of a couple of days ago. As you can see, almost 40,000, approaching 40,000 asteroids and comets that might come to impact with us. And you can see here, it actually did hit 40,000 right there a couple of days ago. Look at that, 40,000. But the rate of discovery is increasing, so we will find more and more and more with more telescopes aimed at the sky. We can also look at by survey and see how many asteroids are discovered each year. You can see that in recent years, they are finding more and more asteroids. So thousands of these every year with the telescopes. There's probably millions of asteroids out there to be discovered. And if you would like to be an asteroid discoverer, sometimes people who discover interesting asteroids get the asteroid to be named after them. So maybe an asteroid will be named after you one day if you become very active in the field of planetary defense. You can also look at by size. And this is how many are discovered for each size. See, the majority of them are not huge asteroids. These are the main concern here. We would like to stop these asteroids because they are the most abundant. Those that are 30 to 100 meters in size and those that are about 30 meters in size, there's probably millions of these out there to be discovered. And so this number is going to grow over the next few years with new telescopes.
Okay, that's about all the time we have because we have to get our kids ready to get on their buses.
Okay.
I want to thank you, all of you guys from Aerospace and Wayne for setting this up. Guys, what do you say?
Thank you. So I have a mission for the students, one mission for me. Do well in school, and you could do anything in life.